Hi, I'm Stephanie Smith. This is Module 1, Chapter 1, Thinking Critically for Math for Teachers 1, Fall Semester 2020. Before we begin, we're going to go through 6 questions. We're going to be kind of following the same pattern. So the first one is we're going to find out what the question's asking, and then we're going to look for clues of how to solve it. That's part of the thinking critically, is using those clues. And then we're going to uh, basically solve the problem by using those clues. And then we're going to check our work. Um, so let's go ahead and begin. So question 1, let's read the question. We're going to place the digits 8, 10, 11, 12, 13 in the circles to make the sums across and vertically equal to 31. We're going to try to find out if there's more than one answer to the puzzle, and we're going to show all the possible number combinations to prove how many combinations to meet that rule of equaling 31. So pretty much what this question is saying is we're going to get 31 to equal, if you see my mouse here, we're going to basically see if across and vertically, we're going to try to make it equal to 31 by using the digits 8, 10, 11, 12, and 13. So let's just start by just doing trial and error. That's the best thing we can do. That's the only clue that we have, is just to basically do different combinations. So let's begin. So we're going to just put 8, 10, 11, 12, and 13 in random order. And if we add it vertically, it's going to be 35. 13, 10 plus 12 is 35. And 8 plus 10 plus 11 is 29. So we know that combination did not work. So let's just try again. So I got 11, 8, 12, 13, and 10. So we're just going to do simple addition and go ahead. And so that is the sum across. And so that equals 31. So yay. So let's see if it's the same vertically. So 11 plus 8 plus 12 is 31. So that is one possible combination. Now, I said we were going to look for clues. I have found by doing this multiple times and trying to solve this, that if we have a large number in the middle for when we're trying to solve this, it's such as higher than, if we do 10, 11, 12, or 13, it is unsolvable. So we won't get the 31. But if we keep the 8 in the middle, it will equal 31. So let me show you an example of that. So I got 8 there in the middle. So we got 12 plus 8 plus 11 equals 31. And we got 10 plus 8 plus 13, that equals 31. So I tried this a lot, and as long as 8's in the middle and you do some sort of combination, and I'm going to list these combinations just from trial and error, if you keep that 8 in the middle and look for those clues, you get 31. And that's a great way of checking your work, is just simply, instead of having to plot them in the circles, just to write it out and try those combinations. Okay. So let's go to part B of question 1, and it says to study the diagram. So we're going to look for the clues from the diagram. So far we see some numbers in this white area, 10, 11, 8, and 7. And then we have 2, 8, 5, and 3 in the blue area. So as we go and study this, we come to find if you take 2 and you add 8, that equals 10. So that's your middle number. If you take 8 plus 3, that's 11. So it's the middle number again. And then 5 plus 3, that's 8. So we got 5 plus 2, that's 7. So that's what we find from the clues of studying the diagram. So now let's find out if I was correct here in our math. So I'm checking my work, and it comes out to be correct. So we got 8 here for 5 plus 3, and then we also got 3 plus 8 equals 11, 2 plus 8 equals 10, and 2 plus 5 equals 7. So from what my clues and checking my work, I should be good. So let's go ahead and go to the question. So part B is we're going to try to solve these next 4 diagrams. So here's our first diagram. And this is the information they've given us. All right, so this is all the information they've given us. So let's go ahead. So we're trying to find what could equal in the question marks. So if we take, since we have the answer of 15, that's our answer. We could just simply subtract 7 to get our answer here. So let's do that. Let's do the math. And here we have is 8. Okay, so now that we have 12 here minus 7, because this is what they gave us. This right now is just a guess. So let's use what they gave us by studying the clues. And we got 12 minus 7, and that's 5. So let's go ahead and plot 5 in there. All right, so now we got to take a chance, and we're going to try to solve. So we're just going to go ahead and do 20 minus 8, which is right here. We're going to take 8 away from 20 and solve this last question mark, and that's 12. And so through process of elimination here, we know that this is correct because we have 7 and 8 equal 15, and then 8 plus 12 equals 20. And then if we have 12 plus 5, that's 17. And then 5 plus 7 is 12. So yay, we've solved it. So let's go to part 2. Or sorry, yeah, part 2 of B. So here's our diagram. And here's all the information they're going to give us. There's our question marks. So let's do the same process again, real quick. 13 minus 6, we got 7. 11 minus 7, we got 4. So now we got 7 and 4. So let's go ahead and take 21 minus 6 to get that last question mark. Now you could do 4 minus 19. Either way it would work. This is just one possible way of doing it. And we have 15. So yay, we solved it. All right, now let's look at question 3 here. Now we're going to use the same method again. All right, those are our numbers in our white, so that's what we're trying to equal the blue to. And here's our questions. So this is all the information we have. So we're going to take 8 minus 3, which we know is 5. Okay, so we're going to put that 5 in there. And then if we take 6 minus 3, that's going to be 3. And if we take 12 minus 3, that's 9. Now, if we put 9 plus 5, that doesn't equal 15. So that's incorrect. So with this problem, we would have no solution. There's no way to solve this. It is incorrect. So no solution. All right, let's do one last one just to make sure we got it right. All right. All right, let's go ahead. 18 minus 8, we got 10. Put that in there. Then we got 9 minus 8. That gives us just 1. Now, 16 minus 10 is 6. All right, and we know 1 plus 6 is 7. So we solved it. Yay. All right, so let's go into question 2. So we're going to sketch all the possible figures that can be formed and calculate the perimeters of each of those figures. So basically, it's going to give us a little more directions, but it's given us, let me make sure I'm reading this right. We have 9 square tiles, and we are just going to assemble those to find the perimeter. Now, I'm done this for you already, and so we're just going to go ahead and I'm going to show you all the different ways I move these 9 squares around. Now, I want you to pay attention to each length of the square. So you have width, and then you have length equals 1, okay? But we're also, when you're counting perimeter, we're going around. So if this is 1, this line is 1. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So I have a perimeter of 18 because I'm adding all the links all the way around of each square. Now, we wouldn't count these links because they're blocked off. So we're only counting on the outside of the line. So we're going to go back to just simply following the directions and plotting different 9 squares. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm just putting these in different ways. So I could simply just move a square. So that's a perimeter of 10. So here I just moved a square. Let me show you a little better. So that was there. Now that's up top, and that changes that perimeter to now to 14. All right, so I took 3 this time and moved it. So that changed it to 16. And then I'm just playing with it. So you can do it however you want as long as you're moving those 9 squares. You can even elongate it. And you would simply count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So that's exactly how you do that. And I really hope you all can see my mouse, or that would not have made sense. So since none of these are blocked off, that's how it equals up to 20. So come to find, no matter how many ways we rearrange these 9 blocks, you will always find a perimeter of either 12, 14, 18, 16, or 20. So to answer part B of this question, the least amount of perimeter was when I blocked everything off as much as I could, and that equaled 12. That was the perimeter. And when I elongated it and stretched it out, it was 20. And so we can move these around all day, but you will only get these numbers. So this being the least, 12, and this being the greatest, which is 20. So that is how you find perimeter. Okay, let's go to question 3. So we're going to look at what will the next 2 figures in this sequence look like. So let's look at our sequence. All right, so we started with 1 dot, and then the next sequence was we added 4. So, and it included the 1. And then we're going to keep looking for clues here of what the next sequence would be like. All right, so they kept the 4 and the 1, and they added an additional, let's count, 1, 2, 3, 4, 5, 6, 7. Okay, so let's keep looking. All right, and then they added, so they have everything the same still, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the only thing that I can notice, and this is just by looking at it, so we could say, okay, well, this is 1 and this is 5 all together. And then we could go, okay, the 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And we could look for the differences that way. So, sorry. So I don't know where I got that number. It gets kind of confusing counting the dots. It really does. So if we kind of focus, and so this is just me counting them out. So I got 1, 5 dots, 12 dots, 22 dots. So what is the difference between what they're adding? So if you take that into consideration, they're actually just adding 3 more plus what they just added. For example, we have 1 dot, and then, okay, so they had 1 dot, and then they added 3 more. So that was 4 more. So what's 4 more? If we have 4 and we add 3, that's 7 dots. And look at that, we got 7 purple dots, and now we have the answer 12, because we keep accumulating. So let's try, see if my idea is correct. So here we have our 12 dots, and we just added 7. So what's more, 3 more than 7? So if we have 7 and we add 3 more, that's 10. So I have 12, and then I added 10, and that's 22. So we figured out the sequence. We're basically adding just 3 more of what was just added. So if we add 3 more to 10, that would be 13. So here is where I found that math. So you got 4, 7, and we're going to try to find the next sequence. We're going to answer that question still. So here's the answer. And let me kind of go through here really quick. So this is what we had before. All right, I like all my little dots. Okay. Okay, so what we did is 12. Let me make sure I'm saying this right. So we were at 22 and we added 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 3 more than that would be 13. So let's check out our math. Okay, and then 3 more than that, it should be 16 new circles. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 11. I'm just going to go all the way. All right. So we got 1 plus 4 plus 7 plus 10. I don't know why it jumped ahead. Let me move this here. I don't want it to jump ahead. Let's go back here. Okay. So if we look here, here's our pattern. So we added 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. And now we have the answer of 35. Well, we got to keep our pattern. So after 13, we got 16, which equals 51. So that is part A answered. Sorry, I clicked ahead. All right, I'm going to move my face back over here so you guys can see me. All right, so it says list of the sequence numbers that correspond with part A. Okay, so here I listed them. So I got the list of sequence numbers, 1 plus 4 plus 7 plus 10 plus 13. And then if we go up 4 more equations, that's where I added the 19, so plus 19. I hope you guys are following along with me here. So 3 more would be 22. All right, and so now we have to compute the 10th term. So we're going to count. This is 1 term, 2 term, 3 term, 4 term, 5 term, 6 term, 7 term, 8 term, 9 term. So we needed 1 more. So we just simply added 3 to 25, got 28. So there is our 10th term. 28 is the 10th term. All right. So an easier way to do that than to keep doing all that addition, I'm going to go back here. Instead of having to do all this in your mind, is to use what we call part E here. What is the pentagonal formula? So here it is at the top here. So we're going to try to calculate, and we already know we're just adding 3. So if we do the plotting of this, it's going to equal 117. And then if we're trying to find the 10th, so that's the 9th. If we're trying to find the 10th, then that is how we solve the 10th. All we're doing is adding 3. So we have the 10, 3 times 10, and we're going to subtract 1. And that's the formula. That was kind of difficult for me to use to know where to plot, but that is the formula, and that is how you solve it. You have to break out your calculators. So, and then if it was nth, then we would just put nth right here, 3 times 9, or 3 times nth minus 1 divided by 2, and we'd get our answer. Okay, so we're moving right along here. So question 4. So it says solve the 4 additional pyramids. That's the question. So now we're going to look for clues on how to solve this. So this is what it's given us. It's given us this example to study, to look for clues. And we're going to just look for a pattern. So right off the bat, I can see a pretty quick pattern. You got 17. 8 plus 9 equals 17. So it looks like this addition pyramid is just simply working its way up. So 3 plus 5 plus 4, what is that? 9, 10, 11, 12? No, there's no 12 here. So it would just be in these 2 blocks. So, and then these 2 blocks. For example, 4 plus 5 is 9, and 5 plus 3 is 8, and it just continues working up. So we got 8 plus 9 is 17. So let's use this to solve these 4 addition pyramids. Okay. So we got 1y, 2 And the very top, we got 15, and we don't know these two. So let's try to figure out. And then the next question is this one and that one. All right, so let's go ahead and try to solve these four. All right, so let's find y. Okay, so what two numbers together could possibly equal 15? So we could do 10 and 5. We could do 13 and 2. There's lots of possibilities. So we're just going to trial and error here, and we're just going to see if we can figure it out. So these are all the different combinations. So I could do the 1 plus 14, 2 plus 13. These are all the different ways I can try to get to 15. So we're just going to input, and I got 7 and 8, okay? So if I got 7 and 8, that equals 15. So how do we solve y? So if I have 6 plus 2, and this is just simple trial and error, me just putting in numbers, using math, like mathematics subtraction. So if I had 8 minus 2, that gave me 6. And then if you also notice, 7 minus 1 is 6 as well. So 6 was a good number to choose from. So let's try this again. Let's do the second question. All right, so second question. These are all the different possibilities. 1 minus 27, 2 minus 25, etc. So let's just plot the numbers that we may hopefully work. And I got 10 and 17. That does make 27. So let's try my math again. Take 2 from 10 and 17 from 9, and we get 8. And it matches our example up here. So yay. All right, let's do the last one. So 7 plus 3, oh, it's given us a shortcut. So we're just going to simply put that 7 plus 3, we're going to put 10 right here. There we go. Now we have half of that equation. So 25 minus 10, we can go ahead and put 15 in this empty box. Okay, I like this question. Okay, so we got 15. So now we're just going to simply subtract 15 and 7. And we get x, which is 8. So yay for the addition pyramids. All right. So this is not question 3. I'm sorry, my PowerPoint is incorrect. This is actually question 5. I don't know why there's a 3 up there. So let me move my little picture of me. All right, we're going down here, guys. All right, so question 5. 4 married couples belong to a bridge club. The wives' names are Kitty, Sarah, Josie, and Ann. Their husbands' names are David, Will, Gus, and Floyd. Using the clues, sort out who is married to whom. Now, this is really fun to me. This is basically we're going to follow the clues, which is what we've been doing this whole time, and we're going to take away the non-possibilities. So let's just read the clue. If Floyd is Josie's brother, then Josie couldn't be married to Floyd because that's wrong. So we're going to go ahead and block that off. So let me put an X here. Okay, so Josie and Floyd cannot be married. Okay, so Josie and Gus, they dated some. So they dated some. That means they're not married. So, but then Gus met his present wife. So we know Josie and Gus are not married. So add an X there. No, Josie and Gus, not married. He's married to somebody else. Well, now it flat out tells us. It says, here is the answer of who married who. Kitty is married to Will. So what does that mean? Well, we could say, yeah, there's a big check mark. We know that Will and Kitty are married, but we can also do something else. We can block off all of Kitty's non-people that she's married to. And we can also mark that Sarah, Josie, and Ann are not married to Will. So let's go ahead and do that. All right, so that blocks all that off. That just took a ton out just with that one piece of information. I wish they would go ahead and tell us who is married to who, but that's not how math works. So Anne has 2 brothers. Now, Anne has two brothers. Well, we know, well, that doesn't help us at all. Anne has two brothers. We're trying to find out who's married to who. So what does it matter that Anne's got two brothers? Well, let's just go to the next clue because we can always go back. Anne's husband is an only child. Okay. Well, if we go back, Josie and Floyd are siblings. Okay. So if Anne's got two brothers, we know that Floyd isn't one of them. So let's just mark that off. Okay, Floyd isn't Anne's brother. Okay. And Anne's husband, we know who's Anne's husband yet? No, we don't. Let's look at this. Sorry. Anne's husband is an only child. So that would also mean, let's see here. Come on. Oh, that's why it's not working. Oh, okay. So Sarah and Anne, just trying to figure out how we got to here. So, forgive me. I'm not perfect at math. Let's just go ahead. So Anne is married to Gus. Let's just backtrack it, you guys. Let's just go back to the beginning of this slide here. Okay, let's go from the beginning. Floyd is Josie's brother. Oh, hold on. I hope you guys forgive me. Okay, so let's continue. Okay, so they can't be married. All right, and then we got Josie and Gus dated some, so that means they can't be married. So that means either, all right, and Kitty is married to Will, so that blocks off everybody else. All right, so we got Will is married to Katie. Oh, that's where I went wrong. So if you look right here, Josie only has a choice to be married to David. That's just process of elimination. But then it also said earlier when I said Anne has two brothers and Anne's husband is an only child. And if we have Anne, her husband is an only child. And we know her husband is not Floyd. That's Josie's brother. So we're going to block that off. Because if Floyd was an only child or wasn't an only child, you get what I'm saying? I think you do. So we know Josie is blocked off. Okay, so how do we get to this last part? Let's see here. Oh, well, we can block that off because David is obviously not married to more than one woman. He's just married to Josie. Okay, so we just still need to figure out who Sarah is married to and who Anne is married to. So and then Anne's husband. Oh, well, there we go. Gus. Hello, Mr. Gus. Anne, process of elimination, has a spot open here. So there we go. Sorry that took me a little long, guys. And hopefully you all were following along with me. That leaves Gus can't be married to Sarah and Anne. So we take away that. And that gives us Floyd is married to Sarah. So to answer the question very quickly, Will and Kitty are married. And then we got Floyd and Sarah are married. And then David and Josie are married. And then Gus is married to Anne. So yay. Sorry that was a struggle, y'all. Okay, let's go to our very last question. And it still says question 3, but it's not. It is question 6. So we're going to create a dot pattern representation of the trapezoidal numbers. and we're going to show inductive reasoning. Now, these are pretty big words. So trapezoidal, if I can even say it correctly, is a trapezoid. We all know what a trapezoid is, and so it's going to be that shaped. And then so inductive reasoning is anytime you use a pattern to predict what comes next. So here we are, we're just going to study this. So we got 1 + 1 + 1. Okay? We're going to build this little trapezoidal shape. Okay? Kind of make it for you a little bit. All right. Something like that. All right. And then there we go. So we're following that pattern. So we got 2 and 2 and 2 and 1 on each side. So then we got 3 and 3 and 3, 2, 2, 1, 1. So here's that little trapezoidal. All right. So here is that with the 4. We're going to just continue on. So we did that. Solved. We built those little dots. So we're going to rearrange the dots now to find the nth trapezoidal number. All right, so we're just going to keep going here. All right, so we got 1 times 3, and 2 times 4, and 3 times 5, and 4 times 6. Or you can just see the general formula. That's how we plot it. So we can use that for all these. 2 + 2 = 8. And then here we are just plotting the formula just to make this easier. So that's that general formula. And there we go. And we've rearranged our triangles. And you can just literally move them however you want. What's important is that they equal up to 24. And all we're doing is we're just continuing to add. And there's that formula for you. This last question is a little bit confusing. If you try not to think too hard and just simply do what it says and rearrange the dots here into columns, that's the easiest thing to do, is what I found. So thank you all for watching my video. Sorry I got a little crazy on 5 and 6, but I hope you enjoyed. Thanks. Bye.